Hello everyone, and welcome to another video on logic. Today, we are going to be discussing arguments and truth tables. Here are some steps I wrote down, which are going to make more sense when we jump into an example, but this is what I have. When we are going to be verifying the validity of an argument, here are the steps. 1, write the argument symbolically, which we've been doing. 2, we're going to join the premise together with the and connective. So you would write premise 1 and premise 2. Number 3, we're going to form a conditional statement with the conjunction from step 2 and with the conclusion. In other words, what it will look like is you will have if premise 1 and premise 2, then your conclusion. You're going to do a truth table with that. If you have all truths in your last column, which is what we call the tautology, then the argument is valid. If there are any F's, even just one F in the last column, the entire argument would be invalid. So let's just take those steps and apply it into what we're talking about here. Now I'm going to start basic with one that's already in symbols. Then the next example will have this in words, and then we'll have to convert to symbols. But let's start with this. We have premise 1. This is called your premise 1, if P then Q. Premise 2 would be not Q. Then your conclusion, and by the way, those 3 dots means therefore, so that's your conclusion, not P. Okay, this is our argument that we want to verify using a truth table. So what we want to do first is we want to create, so go back to the steps we just talked about. You want to take these two premises, right? Put them together, meaning I'm going to have if P then Q, because that's premise 1, and not Q, because that's premise 2, then I'll close the big brackets. And we do an if then with not P because that was our conclusion. Okay, so premise 1 and premise 2, and then we're doing a whole if this, then not P. Now we create the truth table. So let's explain. Let's go back to those steps we talked about in a previous video where we do single statements first, right? Then single negations. Now I have both. I have a not P and I have a not Q. Single negations. Next, remember we did parentheses from left to right. Parentheses, here's a big parenthesis. From left to right, that means I would do the if P then Q first. Then I would combine it. So we would have if P then Q and not Q. Okay, that would be my next step. Then you put the whole thing together, and it looks like we did not need that last column. So I put the whole thing together. Don't worry, we're going to do 3 of these today, so we'll get some practice in here. All right, so we did that. Now we start our truth table. Now remember, we've already done the truth table for P and Q. So we just put 2 T's, 2 F's, right? TF, TF. So this is from a previous video, the basics, when we did the logic, intro to logic, the truth tables. Now remember, not P means I do the exact opposite. Not P, not Q, sorry. Then we do the opposite of what we put in for the Q column. All right, so that was just negating. This is if P, then Q. Now let's go back to our truth table with the if and then. Remember, the only time it is false is if when P is true and Q is false. That's the only time it's false. So looking through here, that happens in this second row right there. Everything else then is going to be true. Now this says we're going to take this column right here and do an and with not Q. So in other words, we're going to take these two columns right here and do an and with that. Now remember, for an and, it can only be true if they're both true. So I'm looking here, that's not the case here. Not here, not here. Yes, I have both true, so that's the only time it's going to be true. All right, I'm going to erase that just because we're going to go to the next one. This is now saying that we're going to do an if-then. So if this column, right, the last column right here, if this, then not P. We're looking at these two. If this, then this. Now remember, with if P, then Q, the only time it is false is if the first is true and the second is false, because that means our condition was met, but we didn't get the conclusion. We didn't get what we should have gotten. So I'm going to go over here. Now this is what we're going to kind of looking backwards, right? This is kind of like your P right now, and this is kind of like your Q. I know it's not, but that's what we're kind of looking at it like. So this is your P, in other words, just as an example, and this is your Q. So I'm just looking to see where the first is true and the second is false. So I don't have any trues until the last column, but the second is true. There is no T followed by an F. That means that this is all true. This is a tautology then, because they're all true at the end, and hence this argument is valid. Okay, first time can be a little overwhelming. Let's go to another example. Now first, I have this chart in your notes that just shows you the standard laws of arguments. If you see them in this form, these would all be considered valid arguments. And what that means is if I were to do a truth table for any of these in this form, I would get a tautology at the end. If I have this form at the bottom, these are called invalid arguments, there would be a false, at least one F in that last column. So these are the different makeups that you can have. But I want to do a little more truth tables with this so that we can get some more practice. Okay, here we have, and let me see if I can, oops, nope. All right, let me go back down here. And I want to move this one down a little bit because that's too far up. Okay, let's start with this one. If news on inflation is good, then stock prices will increase. News on inflation is good, therefore stock prices will increase. Okay, so let's put this into symbols first. If news, so let's call this P, and this one will be Q. That means if P, then Q. The next one says news on inflation is good. That is P. Therefore, stock prices will increase. Well, that was our Q. Okay, now let's put this together. I'll just do it right here. Remember, we put the premises together. So this is if P, then Q, and P, right? Because this is premise 1, this is premise 2, this is our conclusion, and then our conclusion, which is Q. So if premise 1 and premise 2, then Q. All right, so we go to our table. Single statements first, those are already here. Then we work on the parentheses from left to right. So I'm going to have if P, then Q here. Then I put the whole thing together, the whole premise 1 and premise 2. Last column will be the entire argument. All right, so let's do our truth table now. We know that we've got this down by now, right? We've got the pattern. Right? If P, then Q, again, as always, if the first is true and the second is false, that's the only time it is false. Otherwise, it is true. with the and. They both have to be true to be true. So we're looking at this one and this one, P and this. So here they are both true. That's true. But notice that there is an F every other row. So that means the rest have to be F's. All right. Now we put the whole thing together. Now, if you want to look at it like this, remember how we said if the first is true and the second is false, then it is false. So this is the first because we're going this way, and this is the second. Okay, so first is true, second is true. And look, I don't have a true anywhere else. So that means these are automatically true. Okay, again, we look at the last column. It is a tautology, so the entire argument is valid. Now, again, we're not talking about true. Oh, let's go to the next example. I'll show you what I mean. Okay. If you, let me get this down a little. If you perform maintenance on your PC, then you violate the warranty. You do not perform maintenance on your PC. Therefore, you do not violate the warranty. All right, well, let's put this in symbols. If you perform, so this is going to be your Q, you perform maintenance, and violating your warranty would be your Q. The first one is if P, then Q. You do not perform maintenance. That would be not P. Okay? Therefore, what is we saying? You do not violate the warranty, so therefore not Q. Okay. Now we go through and set up our table. So we have our single statements. Do we have single negations? Yes. We have a not P and we have a not Q. And actually, let's go ahead and put this together. I just realized we did not put this together. So premise 1 and premise 2, close. And we do an if then with the conclusion. Okay, so premise 1, premise 2, conclusion. Now, next column, we work on the parentheses. We have an if P then Q. Then we put the whole thing together for the premises. Okay. Then we put the entire argument together in the last, and I ran out of room, on the last column. Okay, now we do the truth table part. All right. Single statements, we've got this down now. Yes, we've got this down. Oops, there we go. Negate your P, right? That's what that means. That's the negation of P, so it's the opposite of what I put. And the negation of Q, oops, there we go. All right, let me just erase a little bit of that. So we know that's definitely a false. If P then Q, we keep doing this one, right? So if the first is true and the second is false, it's the only time it is false. All right, we're doing an and with this, if P then Q, and not P. So I'm looking at these two columns. It's an and, they both have to be true to be true. That does not happen in the first, does not happen in the second. Oh, and yet I did it anyway. Let's try that again. As I say it, I write down the wrong one. Okay, second, we have two false, so that's definitely a false. True and true, oh, that's true. And then true and true. So we have two F's and two T's. Okay. Next, we're doing an if then. So remember, this is the first. The conclusion is our second, right? So the first is true and the second is false. It's false. Okay, that did not happen here. First is true. Nope. First is true. Second is false. Yes. See here, this is a true followed by a false. That becomes a false. And then true followed by true is true. Okay, again, you look at the last column. Notice I have one F. It doesn't matter how many F's are there. As soon as you have an F, the whole thing is an invalid argument. All right, that concludes doing truth tables to validate these types of arguments. And in the next video, we're going to get into our syllogisms and using Euler diagrams. So stay tuned.